Hey guys, welcome back. Happy Monday, happy Monday. As I mentioned earlier, today's lesson is just a little bit of review, some of the essential standards that we talked about first semester, so nothing completely new. Still, we might be a little bit rusty, right? We took about a couple weeks off here. I know we're a little bit rusty, but still, I want you guys to take a moment, pause the video here, try out this warm up, see how much you remember about solving a multi-step equation. All right, when you're ready, go ahead and hit play. All right, so here is the solution to the warm-up. So what I saw first is I saw parentheses. So my eyeballs go directly there. I got to get rid of those parentheses. I got to break out what's inside. So I'm going to go ahead and use distributive property. I'm going to multiply what's in front here, that negative 2 times 2x, negative 4x, and then negative 2 times that positive 1. A negative times a positive is a negative. 2 times 1 is 2. And I'm going to go ahead and bring everything back down. Be careful. You're only multiplying what's inside the parentheses, so not this negative 5. This negative 5, we are going to bring it down. We're going to bring down our equal sign, and then 8. So first things first was distributive property. If you did that, nice, good job. We remember distributive property. Okay, at this point, I see that I can combine like terms. There's a negative 4x, there's a negative 2, and there's a negative 5. I can actually combine two of those. And it's not going to be the negative 4 because that one has an x. It is not a like term. But take a look. Negative 2 and negative 5, because they're both on the same side, literally right next to each other, I can go ahead and regroup those. I can combine my like terms. Negative 2 and a minus 5. I lost $2. I lost $5 more. We lost a total of negative 7. And again, we're bringing everything else back down. Negative 4x, and then my equal sign, and then, of course, 8. And remember, at this point, guys, you didn't have to use inverse operations because you're not going to the other side of the equal sign. But take a look at this step here. I know that I have to get the 8 and that negative 7 together. So now if I want to kick over that negative 7 to the other side, we want to eliminate it. We use inverse operations. So the opposite, the inverse of minus 7 is plus 7. Whatever I do to one side, I do to the other. 7's cancel. You're left with negative 4x is equal to 8 plus 7 is 15. We have one more thing we have to do here. That says negative 4 times x. So the inverse of multiplying by a negative 4 is to divide by negative 4. If we divide both sides here by negative 4, we get x is equal to, can I divide 15 by negative 4? Nope, it's okay. We're going to leave it as a fraction. And it's okay, you guys can leave it as a fraction. X equals 15 over negative 4. All right, so if you got that, nice, good job, good job. If we didn't, it's okay. We're a little rusty right now. That's fine. It'll get better. It'll get better. It'll get better. I promise. It just takes a little bit more practice. All right, let's move on to the actual lesson, guys. So today it is just basically semester one review. What are some key topics from last semester? Some of these skills that will keep popping up in your math careers. So again, just kind of quickly give you guys an overview. We kind of did one at the very beginning here, is solving a multi-step equation. That was essential number 1. All right, just like that warm-up, we're going to practice a few more problems. Another essential standard was calculating your rates of change. Another way to say that was slope. That was your delta y, the change in the y over your change in your x. And we use that little m to represent slope or rate of change. The third essential standard here is dealing with functions. Is, do you remember how to complete a table of values if I give you a specific function, right? You took those x's, we plug them in, and we work it out. So again, completing, can you complete a table of values? So we'll practice that here in a minute. The last thing is, do you remember how to graph a linear equation? Do you remember how to graph a line? And the ones we're going to focus the ones we're going to focus on, they are in standard form. So something like 3x plus 2y equals 6. Remember, this is where we took 2 steps, gave it a quick makeover so that we can actually graph our line. So let's jump into it. So example 1 here. What I'm going to do is I'm going to work out the problem on the left. I'll do this with you guys as the entire class. And then I want you guys to take a moment. Once I go over that we do problem, pause the video, and then try the you do problem. All right, try it, take a minute to see if you can test yourself on it. All right, so let's go through the we do. So just like the warm up, my eyeballs, I'm solving a multi-step equation here. I see parentheses, so I'm going to go ahead and use distributive property and break out what's inside. 3 times 4x, well, that is 12x. What is 3 times negative 3? That is negative 9. bring down everything else, equals, bring down my negative 3x, careful, don't forget about that negative, and then my positive 6. All right, so good. Step 1 is done. We distributed, we got rid of our parentheses. Now, I want to go after my like terms. I see that I have a negative 3x and I have a positive 12x on the left over here. Now, it's up to you which one you want to eliminate, kick over. For me, personally, I would move over the smaller one here. In this case, negative 3x. And again, if I want to go over to the other side, we do have to use inverse operations. So the opposite, the inverse of minus 3x is plus 3x. We're going to do that to both sides. 12x's plus 3x's, that is 15x. Bring down my minus 9, bring down my equal sign, 3x and negative 3x, well, those go away. And we bring down our 6. All right, great. We're down to a two-step equation. Very similar. I noticed that I have a negative 9 and I have a 6 that I need to get together. Those are my like terms, but I got to kick one over to the other side. And I'm going to kick over that minus 9. So we're going to do plus 9, the inverse, plus 9 and minus 9 go away. We get 15x is equal to 6 plus 9 is 15. We got one more thing we need to take care of. 15 times x, what's the opposite of multiplying? The inverse, that is to divide. So if we divide both sides here by 15, we get x is equal to 1. Worked out very nicely. We got x equals 1. All right, guys, at this point, I want you guys to take a minute, pause the video, try the you do problem. When you guys are ready, go ahead and hit play, and I'll show you guys pretty much the solution. We do a little bit of movie magic here, and then you'll see the problem all worked out. All right, so there it is with a little bit of movie magic. You guys can see the solution, and let me just kind of briefly go through it. So first things first, guys, is I went ahead and I distributed. I multiplied what was inside of my parentheses here by that negative 2 out in front. So double check your signs. If you made a mistake, it might have been there. Negative 2 times 4 is negative 8. Negative 2 times 2 is negative 4. At this point, I saw that I had like terms, 2x and a negative 8x. I decided to get rid of that minus 8x by doing plus 8x. So those canceled. And then the 2x and the 8x gave me 10. I did very similar thing here with the negative 3 and the negative 4. I kicked over that minus 3 by doing plus 3 to both sides. So the 3's obviously cancel out. Negative 4 plus 3 was negative 1. And then at the end here, we just divide both sides by 10. Of course, negative 1 does not divide nicely by 10. So we go ahead and leave it as a fraction. All right. Example 2. This is rate of change, Remember, rate of change, what is rate of change? Another way to say rate of change, that's basically just saying slope. And we use the letter M to represent slope. And remember, that was the change in the y's, delta y over delta x. It's a comparison of how much my y's are changing over how much my x's are changing by. So let's take a look at this first. There's two problems on the we do section here. So let me take a look at the x's. Well, my x's, every time I scoot down, let me find a color that pops here a little bit more. Every time I scoot down from 5 to 10, from 10 to 15, from 15 to 20, from 20 to 25, I see those numbers are increasing. So I know we're adding. How much are we adding? We're actually adding plus 5, plus 5, plus 5, plus 5. Every time we're scooting down there, we're increasing by a total of 5. What about the other side? What about the change in the y's? Let's take a look at the change in the y's. Let me use a different color here. Hopefully it stands out. How do I go from negative 50 to negative 40, negative 40, negative 30, negative 30 to negative 20, negative 20 to negative 10? Those numbers are actually increasing. They are getting bigger. I know it looks like they're getting smaller, but we're getting closer to 0, closer to those positive numbers. Feel free to draw a number line if you want to visually see it. But we are adding plus 10, plus 10, plus 10, plus 10 every time we're scooting down there. So my y's are changing at a rate of plus 10. My x's here are changing at a rate of plus 5. So what is our rate of change? What is our slope? So we're going to say m is equal to, and please be very careful, it's the change in the y's. So my y's, again, we're changing by 10 over how much were my x's changing by? They were changing by a rate of 5. So again, please be careful. I'm not just looking for 10 and 5. I need that ratio. I need that fraction. And we can even do better than that. If you can divide it, go ahead and divide it. What is 10 divided by 5? That is 2. Our rate of change here, guys, is 2, or 2 over 1. Let's try that one more time. Over here on the right-hand side. Let's see. I'll start off with my y's this time, so we can take a look at the y's first. Let me change colors here. So the change in the y's, how do I go from 12 to 8, 8 to 4, 4 to 0, 0 to -4? Well, my numbers are going down. I know I'm subtracting. Every time I'm scooting down, I'm taking away 4. The y's have a rate of change right now, just the y's of -4. Let's do that same thing. Let's figure it out for the x's. How do we go from 2 to 4, 4 to 6, 6 to 8, 8 to 10? That looks like we're adding 2 each time. Plus 2, plus 2, plus 2. So my x's are changing at a rate of +2. So when we put all of this together, well, slope, rate of change, m, is equal to the change in my y's, which was -4, over the change in my x's, which was +2. And again, we can do better than that. -4 divided by 2 is -2. My rate of change here is -2, or -2/1. All right, guys. So again, take a minute, pause the video. I want you guys to try this one more time on your own in the you do section. So find the rate of change, find that slope, and then when you're ready, go ahead and hit play. You'll see my solutions with a little bit of movie magic. All right, so there you have it. So for the first one, the rate of change, your slope, guys, it should have been 11 over -3. My y's here, we're changing at a rate of +11. That's why you see the 11 up above. And my x's were changing by -3 every time. And then again, 11 over -3 doesn't divide nicely, so go ahead and leave it as a fraction. That's perfectly okay. Now for the second one here, take a look at my y's. My y's were changing by +6. That's why you see the +6 right there. And then my x's were changing at a rate of -2, -2, -2. So that's why you see that -2 down there. And of course, 6 divided by -2, we can do a lot better than that. We can actually divide that. 6 divided by -2 is -3. So our slope there, our rate of change, is -3, or -3/1. All right, moving on to examples 3 here. Table of values. Do remember how to complete a table of values. So this is where you are inputting. You got to make sure you input in the correct spot. So remember, the left side here, the left side of that table of values, that represents your x's, right? And take a look. This is where you want to substitute if you're substituting in for x. Now the right side, this normally represents your y. In this case, it's your f of x. F of x and y are the same thing. This is just a bougier, fancier way to say that. So again, if we are given our f of x, guess where that's going to go? That's going to go in our f of x section there, right? Think of that as you're plugging it in for y instead of x this time. So let's take care of the first 2 rows here. When x is 2, well, we're going to take that x value of 2, we're going to plug it in there. This is kind of the work that you should be showing. And you'll see this in textbooks. Sometimes they'll say instead of saying f of x, they'll actually show the 2 there, just to remind us of what are we plugging in. We're plugging in a 2. And so let's rewrite it. -2, instead of that x, we're going to multiply it by the 2 that they gave us here. So -2 times 2 plus 3. And again, this f of 2, that's just to kind of keep track. You're not really doing anything with it. It's just to remind you that you plugged in a 2 for your x. What is -2 times 2, though? That is -4. Bring down that plus 3. F of 2 is equal to what's -4 plus 3? That is -1. There we have it, there we have it, there we have it. All right, let's go through and do that basically all over again, for 5 now, for 5. So I am going to need a little bit, well, I'll leave that up there for a minute. So let's go and do that one more time for 5. So we're going to take that 5, since it's in the x column, that's my x value, we're going to plug it in for the x, and I'll plug it into the f of x part right there. See, just to remind you of what we are plugging in. So now it's going to say f of 5 is equal to -2. Instead of saying times x here, we're going to say times 5 plus 3. And again, f of 5, just to keep track what number we used. -2 times 5 is -10. -10 plus the 3 we bring down, that is going to give us -7. F of 5 is -7. That's telling me that when I plugged in 5 for x, my output was -7 for my f of x. So there we have it, there we have it. All right, so that's when you plug in your x, or you're given x, excuse me. So again, if you're ever given x, plug in for the x value. Now, what if we have this problem, but it's a little bit backwards? I'm going to need a little bit of room here. I need a little bit of room, so let me erase that. Let me erase that, let me erase that. What if this time they give us our f of x? They gave me the number on the right side of that table of values. So again, that negative 13, it's my f of x. You're actually going to replace the entire f of x here. You're substituting for the whole thing. Remember, think of that as y. So we're going to replace that entire thing here with negative 13 is equal to negative 2. And again, it's okay not to replace this x because that is what you're actually trying to find. You're trying to find that missing spot there. So you'll see this turns into that warm-up problem, that multi-step equation. So let me keep going, plus 3. So again, all I did is if they give you your f of x, plug it in for the entire f of x portion. All right, how do I solve this two-step equation? This should be review right here. How do we get rid of that plus 3? We subtract 3 from both sides. Minus 3, minus 3. Well, careful here. Negative 3 minus 3 is negative 16. You're solving a two-step equation. We bring down the equal sign, the negative 2x. All right, I got one more thing I got to do here. If I divide both sides by negative 2, we get negative 16 divided by negative 2 is 8 is equal to x because those two cancel out. Now notice 8 is equal to x, which is great because I was trying to figure out the x here. The x is going to be 8. When x is 8, f of x is negative 13. Your output value is negative 13. All right, let's try that one more time. But we're going to try that with, where's the number that they gave me? Negative 19. Negative 19. So let's try that one more time. And again, negative 19, that is my f of x. So I'm going to literally replace that entire f of x portion with a negative 19 is equal to, whoops, I almost forgot that negative. Almost forgot. Equals negative 2x plus 3. Let's work this out. If I subtract 3 from both sides, careful here, negative 19 minus 3, we owe $19. We owe 3 more dollars. We're going to owe 21 is equal to, excuse me, 22, not 21. Negative 22 is equal to negative 2x. All right, we got one more thing we got to do here. If we divide both sides by negative 2, we are going to go ahead and get 11. 11 is equal to x. That is our input. All right, and we've successfully completed that table of values. All right, guys, take a couple minutes. Please try the you do. And again, when you're ready, go ahead and hit play. I'll give you guys the solutions. All right, guys, there you have it. So again, the table is complete. I left two examples. The first one here in red is for that very first row. I plugged in 3 for my x, and then the second example there in green, that is when they gave me my f of x, which was 13, and then my x value was 4. All right, so moving on here. Graph a linear function. So we're going to go ahead and graph these guys. Now, again, they are in what we call standard form. I do have to give these guys a quick little makeover so we can put them in slope-intercept form. It just makes our life a little bit easier. And remember, the way we do that is we start by kicking over your x. You want to get the y by itself. Y equals mx plus b. So let's get rid of this minus 3x by adding 3x's to both sides, plus 3x plus 3x. Those, of course, cancel. We bring down negative 4y is equal to, and you cannot combine a 3x with a negative 8, so we write them next to each other. Those are not like terms, but they're going to sit on the same side over there on the right of the equal sign. All right, I got one more thing I got to do. How do I get rid of multiplying by that negative 4 in front of the y? Well, we're going to divide every single thing here by negative 4. Be careful with your signs. When I bring this down, we're going to bring down y is equal to 3 over negative 4 does not divide nicely, so we're going to leave that as a fraction. 3 over negative 4x. Negative 8 divided by negative 4 is a positive 2. That right there, I'm going to go ahead and box that in so it stands out, but that is good to go. We can graph that. That makes our life a lot easier. Now, I didn't give you guys graph paper today, so do the best you can, guys. It does not have to be, it's not going to be the prettiest thing in the world for me either. But again, as long as we get a pretty decent picture, we're going to be okay. So I'm going to go, let's see, 1, 2, 3, 4, 5, 6, sure. 1, whoa, go back. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, negative 1, negative 2, 3, 4, 5, 6. All right, so if you remember, how do we graph something in y equals mx plus b in slope-intercept form? We start here at the very end, which is my y-intercept. So on the y-axis, it looks like we're going to go to positive 2. So I go up 2 spaces, and here we are. That is going to be our very first point. Now remember how to read your slope, guys. This is how you get the rest of the points. It's all right there. 3, positive 3 over -4 because it's a +3. That is telling me to go up, climb up 3. And then because that's a -4, that is telling me to go to the left 4. So be careful on this one. We are going to go up 3 and then to the left 4. Up 1, 2, 3, left 1, 2, 3, 4. And again, I know it's not the prettiest thing in the world. Roughly right there, that is up 3 and left 4. What else can I also do? I could have also gone down. If I change the pattern, if I change both directions, we could also go down 1, 2, 3, and then to the right 1, 2, 3, 4. Notice all those 3 points do line up. So I'm just going to go ahead and connect it. And there we have it. Put arrows on both ends. That line does not stop. We could keep it going if we had enough space and time. All right, so just like the last ones, guys, take a minute, pause the video, try that second you do problem for a minute. All right, guys, so there is my second equation. I went ahead and fixed it. I ended up with y equals 3x minus 2, or 3 over 1, right? I went ahead and I put that 1 underneath if we don't see it. I did start at my y-intercept, which was -2. Then I went up 3 spaces to the right 1. I kept that pattern going, and I also went down 3 and to the left 1 just to get a much better picture. All right, guys, so here's the deal. At this point, we are done with the lesson. You guys have 6 problems for today's class activity. All right, so the first couple here, you're solving a multi-step equation. For the next two, you guys are calculating rate of change. Oh, sorry, for the next one, you're calculating rate of change. For the fourth one, you are completing the table of values, right? You're filling in those missing boxes. And then for the last two here, number 5 and number 6, you are graphing. And again, give me the best graph you can. I know you guys don't have graph paper, so as long as I see 2 points and you guys go ahead and connect those, that's going to be okay for me. All right, guys, take care. Have a wonderful day. If anything, please feel free to reach out to me. Before you guys also turn this in on a separate piece of paper into the inbox, make sure you guys double check your work with my sub. They do have the answer key. All right, guys, take care. Jump right into it.